Imagine walking down the hallway of your school or office long after everyone has left for the night, or standing in the center of a massive, silent shopping mall at 2 in the morning. In architecture, these are called liminal spaces. They are environments designed exclusively for transition, hallways, stairwells, and lobbies meant to be moved through, never occupied. When you find yourself in one alone, the silence feels heavy. A specific, uncomfortable anxiety begins to tighten in your chest. This discomfort is a universal response. It is a shared biological alarm system that triggers across the human population when certain spatial conditions are met. The mainstream psychological consensus is that this feeling is just a simple fear of the unknown. But that explanation doesn't quite fit. You aren't actually looking for a physical threat hiding in the dark. The unease comes from the environment itself. Without human activity to give them purpose, these spaces feel dead, fake, and entirely artificial. This visceral rejection stems from a data mismatch. Your brain expects the noise and movement of a living world, but finds only a hollow, static imitation. This mismatch suggests a different reality, that our universe is operating as a highly advanced simulation. Every computational system, no matter how vast, faces the same engineering constraint: finite processing power. This map illustrates how the system conserves energy, concentrating rendering power on densely populated areas of human observation. As nodes move away, servers deprioritize that sector to save memory. The detailed world instantly devolves into basic wireframe grids. What we perceive as a lonely, deserted space is a localized instance of the universe throttling its server resources. Consider modern video game design. The world outside player vision simply does not exist. It waits as blank base code. Entering an empty hospital or an abandoned building at night is the real-world equivalent of walking into those unrendered assets. The deafening silence and the thickness of the air happen because the system hasn't allocated resources to generate complex physics for that zone. Your biological code reacts with severe anxiety when it detects this sudden, massive drop in the environment's resolution. This surge of existential dread is a hardware-level error. Your biology is flagging a system failure as you wander through the background assets of reality. This explains the strange nostalgia these places evoke. You feel like you've been there before, because in a way, you have. These environments are base templates, the foundational structural blueprints the simulation uses to copy, paste, and build out our physical world. Lingering in a template for too long inadvertently exposes you to the bare, unpolished infrastructure of the underlying simulation. Recognizing these foundational blueprints breaks the illusion of a solid universe. Once you see the seam in the code, you stop seeing a unique hallway and start seeing the structural repetition of the engine. But there is a reason your instincts tell you to leave. Staying inside an unrendered zone for too long is dangerous. The system's operating logic eventually identifies and flags active users wandering through these inactive, low-resource areas. In that moment, you are categorized as a wandering anomaly, a rogue line of code operating outside the designated play area. The standard procedure for any active computational system dealing with an anomaly is immediate correction, or sudden deletion. Next time the biological alarm sounds in an empty corridor, do not look back. Just keep walking before the simulation logs you out.